Now, from the China Meteorological Administration, let's welcome Muyuan to present the solar radiation prediction on the monthly time scale using machine learning.
Sorry, but I can't share my screen. Um, can you hear me?
Yes, please try it now.
Uh, okay. Okay, sorry. Thank you. Thank you. It's my honor to have the opportunity to address such a distinguished audience. My name is Muyuan, and I'm now working in the Wenan Solar Energy Center of China Meteorological Administration. Today, my topic is predict solar radiation on the monthly timescale based on machine learning. First, let me begin with some background information. As can be seen from the table, renewable energy prediction is essential to all timescales. Here, we only focus on the monthly timescale. On this timescale, the prediction can be applied to construction decisions and midterm planning, such as planning for maintenance works, anticipating energy prices and cash flow, anticipating cooler or warmer than normal seasons, and then we can schedule more or less power supply. So these benefits promote us to build a model for the monthly prediction of solar radiation. To construct model, we need data and some techniques. The data we used includes monthly mean total shortwave radiation at meteorological stations, and then the EIA5 reanalysis data. We used a total of 33 parameters, and the MRI CGCM hindcast data, a total of 20 parameters. For the method, first we used EUF to extract the leading modes and pieces of the observed solar radiation data. And then we calculated the correlation coefficients between pieces and the 33 parameters. For each parameter, the regions with significant correlation coefficients, both for the reanalysis and hindcast data, are averaged as predictors. Next, the pieces as predictants and the predictors are used to construct the prediction model through piecewise regression and some machine learning methods, such as random forest, gradient boosting, and decision tree. In step 4, we first construct the new pieces with our prediction model and then use the new pieces and old EUF to predict the monthly solar radiation. In the end, I would like to show you some results. We take January 2023 as an example. You can see the predicted spatial distribution of GHI, the global horizontal irradiance, is well consistent with observation, with a significant correlation coefficient of 0.95. But if we subtract the climatological mean of GHI, that is GHI anomaly, the predicted results have some discrepancies with the observation, mainly over Mid-Eastern China and Southern China. Okay, that's all for my presentation. Thank you so much.